Good day, ma'am. I am Pamela Stephanie Erico. My topic is about Spearman's rank rho correlation. Learning objectives. In this chapter, you learn monotonic function to Spearman correlation, Spearman's rank order correlation, values can the Spearman correlation coefficients RS can take, and how to rank data. To understand Spearman correlation, it is necessary to know what a monotonic function is. A monotonic function is one that either never increases or never decreases as its independent variable increases. Monotonically increasing. As the x variable increases, the y variable never decreases. Monotonically decreasing. As the x variable increases, the y variable never increases. Not monotonic. As the x variable increases, the y variable sometimes decreases and sometimes increases. What values can the Spearman correlation coefficient RS can take? The Spearman correlation coefficient RS can take values from positive 1 to negative 1 RS. Positive 1 indicates a perfect association of ranks. A RS of 0 indicates no association of ranks. The closer RS to the 0, the weaker the association between the ranks. Correlation is an effect size, and so we can verbally describe the strength of the correlation using the following guide for the absolute value of from the range of 0.00 to 0.19, it is very weak. 0.20 to 0.39 is weak. 0.40 to 0.59 is moderate. 0.60 to 0.79 is strong. And 0.80 to 1.0 is very strong. Spearman's correlation. Spearman's rank correlation or Spearman's rank rho is named after Charles Spearman and often denoted by the Greek letter P rho or as R sub S. It is a method of measuring or testing the strength and direction of association, positive and negative, of the correlation between two rank variables. It assesses how well the relationship between two variables can be described using a monotonic function. The Spearman's formula is P equals 1 over 6 summation of D sub I squared over N times N squared minus 1, where P denoted to Spearman's rank correlation coefficient. D sub I is denoted to the difference between two ranks of each observation, and N is denoted to the number of observations. How to rank data? In some cases, your data might already be ranked, but often you will find that you need to rank data yourself. Thankfully, ranking the data yourself is not a difficult task and is easily achieved by working through your data in a table. Consider the score of 5 students in math and science that are mentioned in the table. Here in the table, we can see 5 students, which are student A, student B, student C, student D, and student E. In the second table, we can see their scores in math, and the third table can see their scores in science. Student A got 35 score in math, while 24 in science. Student B got 20 in math, while 35 in science. Student C got 49 in math and 39 in science. Student D got 44 in math and 48 in science. Student E got 30 score in math, while 45 in science. Step 1. Create the table for the given data. Since the first example already has the given table, let's proceed to step 2. Rank both data in descending order separately. The score with the highest value should be labeled 1, and the score with the lowest value should be labeled depends on how many cases you have. In this example, we have 5 cases or we have 5 students. So the highest value should be labeled 1, and the lowest value should be labeled 5. In mathematics, student C rank first, student D rank second, student A rank third, student E rank fourth, and student B rank fifth. In science, student D got rank first, student E rank second, student C rank third, student B rank fourth, and student A rank fifth. Step 3. Calculate the difference between the ranks D and the squared value of D. To get the value of D, we need to subtract the rank from the first variable to the second variable. Our first variable is mathematics, while our second variable is science. So 3 minus 5 is equals to negative 2. 5 minus 4 is equals to 1. 1 minus 3 is equals to negative 2. 2 minus 1 is equals to 1. 4 minus 2 is equals to 2. Step 4. Add all your d squared values. We all know that to get the d squared value, we need to multiply the d value by itself. So, negative 2 multiplied by itself is 4. 1 times 1 is 1. Negative 2 multiplied by itself is 4. 1 multiplied by itself is 1. 2 multiplied by itself is 4. Step 5. Insert the values into the formula. We all know that our value is P equals to 1 minus 6 summation of D sub I squared over N times N squared minus 1. Our D sub I squared, its value is 14, while our N, or the number of data, or the students we have, is 5. So, input the 5 times 5 squared minus 1. So, 6 times 14 is equivalent to 84, while 5 times 5 squared minus 1 is equal to 120. 1 minus 84 over 120 is equivalent to 0.3. The Spearman's rank correlation for the given data in example 1 is 0.3. Therefore, there is a very weak correlation between the two ranks. Let's proceed to the second example 2. Using the information given in the table, find the Spearman's rank correlation between the variable 1, which is height in centimeter, and variable 2, which is the weight in kilogram. So, in our variable 1, student E ranked first with 190 centimeter height, student B ranked second with 182 centimeter height, student A ranked third with a value of 170 centimeter height, student D ranked fourth with a value of 166 centimeter height, and student C ranked fifth with a value of 153 centimeter in height. In our second variable, student D ranked first with 80 kilogram in weight. Student D gets second for 75 kilogram in weight. Student B ranked third for 69 in kilogram for weight. Student C ranked fourth with 60 kilogram weight. And student A ranked fifth with 54 kilogram in weight. So to get our D value again, we need to subtract the rank from the first variable to the second variable. So D minus 5 is negative 2. 2 minus 3 is negative 1. 5 minus 4 is 1. 4 minus 1 is 3. And 1 minus 2 is negative 1. So to get again the D squared value, we need to multiply the value to itself. So negative 2 squared is 4. Negative 1 squared is 1. Positive 1 squared is 1. Positive 3 squared is 9. And negative 1 is 1. This d squared value should be added. So we get our di squared formula. So 4 plus 1 plus 1 plus 9 plus 1 is equivalent to 16. So substitute the value of di squared and the value of n. P equals 1 minus C summation of 16 over 5 times 5 squared minus 1. 6 times 16 is equivalent to 96. 5 times 5 squared minus 1 is equivalent to 120. So 1 minus 96 over 90 is equal to 0.2. The Spearman's rank correlation for the given data is 0.2. Therefore, there is a very weak correlation between the ranks of the student's height in centimeter and the student's weight in kilogram. Sample 3. Calculate the Spearman's rank correlation coefficient of Ella's grade. Ella's grade in English is 56, 75, 45, 71, 62, 64, 58, 80, 76, and 61. Ella's grade in Filipino is 66, 70, 40, 60, 65, 56, 59, 77, 67, and 63. Remember our first step. Our first step is to create a table with the given data. So here we put Ella's grade in the table, which is her grade in English and her grade in Filipino. So we rank her grade in English into 1 to 10 because the given data give 10 values of Ella's grade in English and 10 values in Ella's grade in Filipino. So we should get the D value. So 9 minus 4 is equals 5. 3 minus 2 is equals 1. 10 minus 10 is 0. 4 minus 7 is negative 3. 6 minus 5 is 1. 5 minus 9 is negative 4. 8 minus 8 is 0. 1 minus 1 is 0. 2 minus 3 is negative 1. 7 minus 6 is 1. So D value again, we need to multiply it by herself. So 5 times 5 is 25. 1 times 1 is 0. 0 times 0, we all know that it is 0. So, and negative 3 multiplied by itself, we know that negative multiplied to negative becomes positive. So the value of, or the D squared of negative 3 is positive 9. 1 multiplied by itself is 1. Negative 4 times negative 4 is positive 16. 0 times 0 is 0. 0 times 0 is 0. Negative 1 times negative 1 is 1. 1 times 1 is 1. We need to sum again the values in D squared. So 25 plus 1 plus 0 plus 9 plus 1 plus 16 plus 0 plus 0 plus 1 plus 1 is equivalent to 54. D I sub squared is 54. So input here in our formula. So 6 times 54 is 326. 10 times 10 squared minus 1 is 990. So 1 minus 326 over 990 is 0.67. So the Spearman rank correlation for the given data is 0.67. Therefore, there is a strong correlation between Ella's rank in English and Ella's rank in Filipino. Sample 4. 7 singers perform at a local singing competition. After the performance, the 2 judges rank the 7 contestants in order. So the singer that each judge likes best rank 1. Calculate the correlation coefficient using Spearman's rank correlation. We can see that the first judge give 4 points to both contestant number 2 and contestant number 5. And the second judge give the score of 9 to both contestant number 2 and contestant number 6. And he gives 7 points to contestant number 1 and contestant number 5. So what will happen if they have the same score? Let's just take this score from Judge 2. So he gave 9 points to contestant 2 and contestant number 6. So what will be their rank? Since they have the same score, we need to rank them, not the rank from 1 and 2. So we need to get the median of 1 and 2, which is 1.5. So both contestant number 2 and contestant number 6 got the rank of 1.5. So again, let's proceed to the value of D. So to get the value of D again, we need to we need to subtract the rank from first variable and the rank from second variable. So 2 minus 4.5 is negative 25. When we squared it, it is 6.25. 65 minus 1.5 equals 5. Multiplied by itself is that 5. 4 minus 7 is equals to negative 3. Multiplied by itself equivalent to 9. 5 minus 6 is equal to negative 1. Multiplied by itself becomes positive 1. Because we'll know that negative multiplied to negative becomes positive. 6.5 minus 4.5 is equal to 2. Multiplied by itself is 4. 1 minus 1.5 is equals to negative 0.5. Multiplied it by itself is 0.25. 3 minus 3 is equal to 0. Multiplied it by itself becomes 0. Now we need to sum up all the values in this square. 6.25 plus 25 plus 9 plus 1 plus 4 plus 0.25 is equivalent to 45.5. Our DI squared value is 45.5. And our number of observation is 7, which because we have 7 contestants. Then 6 times 45.5 is 273. 7 times 7 squared minus 1 is 336. So 1 minus 273 over 336 is equivalent to 0.19. Therefore, there is a very weak correlation between the rank from Judge 1 and Judge 2. Let's proceed to the last example. It's giving gift day. Mother and father will give gifts to their children Luana, Nard, Jan, and Mia. Mother give 1 gift to Luana, 2 gifts to Nard, 3 gifts to John, and 4 gifts to Mia. Father give 5 gifts to Luana, 4 gifts to Nard, 4 gifts to John, and 5 gifts to Mia. Let's calculate the Spearman correlation between the first variable and the second variable. Our first variable is the mother, and our second variable is the gift given by the father. Mia got 4 gifts, so she ranked first. John got 3 gifts, so he ranked second. Nard got 2 gifts, so he ranked third. And Joanna with the least gift received rank fourth. While in the second variable, father give 5 gifts both to Joanna and Mia, which again they will be ranked from median of 1 and 2 because they are 2. So the median of 1 and 2 is 1.5. So both Joanna and Mia rank 1.5, while Nard and John rank 3.5. Why they rank 3.5? Because since we have 4 observation, 1.5 and 1.5 is considered 1 and 2. So next is we need to start from 3. So they are both 4, which is Nard, and John, which is 2. So they should be start from 3 to 4. And the median of 3 to 4 is 3.5. Calculate the D value and multiply the D value of self. 6.25 plus 0.25, 2.25 plus 0.25 is equivalent to 9. Our DI sub squared is 9, and the number of our observation is 4, which are the 4 children. And 6 times 9 equals 54. 4 times 4 squared minus 1 is equals to 60. 1 minus 54 over 60 is equivalent to 0.1. Therefore, there is a very weak correlation between the rank from the two variable. That concludes my report. That would be all. Thank you.